everybody. Welcome back to another episode of The Skeleton Crew. I'm your host, Jen Callahan, and today I have a great guest with me. His name is Lennart Schulenburg. He is joining me from Germany, and he's here to talk to us today about a different field that X-ray is being used in. So generally, we're talking about healthcare and the field of radiology, but he's going to be talking to us about his company, VisiConsult, and that's an X-ray system and solutions company. So Lennart, thank you so much for being with me today.
Thank you for having me.
Oh, my pleasure. So I'm really excited to delve into what your company actually does, because there's a bunch of different sections or segments. I don't really know the right word to use for it, but that VisiConsult has. So I'm going to let Lennart go ahead and explain what the actual company is that they're using X-ray for that's not healthcare related.
Perfect. Start at the core. We are X-raying everything, or let's put it this way, our customers are X-raying with our systems, everything that is not living. So we are not active in the medical space. We don't X-ray humans. We don't X-ray animals. We X-ray, for example, casting parts. We X-ray metallic welds and these things to check their integrity, whether these things function correctly, whether there's any manufacturing defects inside. And this is a field called non-destructive testing, because we are effectively doing the same thing like medical healthcare providers do, just that we're not checking bones, but we are checking metal parts. But we do this in an equally non-destructive way.
Okay. So generally, there's radiopaque and radiolucent materials in X-ray or, CAT scan, things like that. And generally, X-ray cannot get through metal. Now, is there some variation of X-ray that you're using that you can get through metal?
Excellent question. Really good, because we use the same X-ray as you use in medical, but we use much more energy. Okay. So a normal system of ours starts at 225 kV. While I know in the medical space, you're more like in the 40 to 60 kV range if you look at tissue. And you might correct me whether maybe that is even too high already. But this is where we start. We have systems that go up to the 450, 600 kV range, and even going up to the linear accelerator range where you talk about MEV exposure. And there's another distinct difference. We have all the time in the world when it comes to exposure. You want to limit exposure when it comes to humans, absolutely clear. But we have exposure times that are minutes long, or we have CT scans that take 10 hours. And we spin the part, by the way, which you would never do with a human being, right? You spin around the human, but we actively don't have all these constraints. So we take much more energy, we take much longer time, and we can do things with our object of interest that you could never do in medical.
Wow, that's really interesting. For those of you who are listening who might not know exactly what kV is, it's the force of the X-ray coming out. Did I explain that right?
That is right. So you look at kV and MA, right? And well, kV is like the force of this thing coming out, which is determining the penetration. The MA, the milliampere, would be like how much photons would come at a time. And we use tubes that have around 1,000 watts sometimes. So it's a lot of photons coming. You would never expose a human to that dose. Mm-hmm. But if you have a metal object, you don't care.
Right. So as you were saying, you were actually kind of low on the end of the kilovolts that we use. So for an extremity, you're usually using somewhere around like 50 kV. And then once you get into thicker body parts, you're using a higher kV. So your highest kV is, I'd say, usually like 125. And that's for a chest X-ray. Say about like between 70 and 80 for, your thicker extremities or your abdomen. But yes, highest is 125. So for those of you who are listening, kind of gives you an idea that how much higher that you're starting at the 200s and you're going up, and you said into the linear accelerator. So, and that's really being used for radiation therapy, right?
Exactly. So if you as a human would accidentally been trapped in one of our industrial inspection systems for longer than a minute, your body would start dying effectively, which is why there's a lot of safety measures in place. There's lead-lined cabinets around it, a lot of safety protocols on the inside. So actually that should and does never happen. But it puts these things in perspective. Dose at this rate is deadly. And you have to do measures, to put in place measures that are protecting human lives.
So would you almost kind of equate that to different nuclear destructions that have happened, like Chernobyl, almost like how the people were exposed to so much radiation in such a short amount of time that exactly. Sort of actively dying.
In that amount of dose where these things actually get very detrimental to your health in the long run, but potentially also in the short run if you just catch enough dose. But this is actually, why there's companies like us who know how to handle X-rays, who know how to put the safety measures in place. And there's, of course, a lot of certification around it. Like the FDA in the US is a big governing force that makes sure X-ray systems being put in circulation are safe to use in an industrial sense.
Mhm. Now, for the people who are operating equipment that are doing the testing, what's their background look like?
Yeah, that's interesting because it's a little bit different than in the medical field. Most likely people from material sciences. So these are people that are looking at the metallurgists, that are looking at the integrity of parts. So there is no real profession X-ray tech. I mean, there is a profession called non-destructive testing, and X-ray inspection is one subfield next to ultrasonic inspection. So you'll be surprised there's many more medical technologies that are applied on materials too. So there is kind of like a trade that you can learn, but there is no general field of activity like doctors and X-ray techs and all these things. It's mainly people coming from the world of quality and material science.
So, your company's been around for some time and it was started by a family and it's still pretty much family run and within the family.
Yes, that is the case. We were founded in 1996 by my father. We started as a one-man shop. My mother was our second employee. We grew slowly over time. We were none of those supercharged startups you see these days. We grew completely organically, no investors, slowly, steady, conservatively. We grew into 250 people, which we've just hit last year. We're a global business, 80% export quota. And to our customers are the likes of Blue Origin, SpaceX, Boeing, Pratt & Whitney, BMW. So names that everybody of us is aware of and knows about. We focused on the high-tech equipment side to really enable these cutting-edge technologies like additive manufacturing, 3D printing, and space travel.
Wow. Where was the vision for your dad to start up a company like this? It's not really something that you kind of like pick out of the air, I feel like some people who go into entrepreneurship, like they're opening up a restaurant or something along those lines, but your dad started up an X-ray
Yeah.
company.
Yeah. See, he was working as the head of development for one of the oldest X-ray business in Germany. They started to work with Mr. Röntgen, the founder of the X-rays. This company was bought by GE, General Electric, back in the days. And what he did not want to be part of a multi-billion global conglomerate that was more like a faceless entity. So he really wanted to have purpose and work on something that drove him forward and energized him. And so he quit. And that's when he started to found VisiConsult as a spin-off from GE, you could say. But there was no broader plan. It was more like a necessity that this was the thing that he did not want to do. And he saw the chance in building something on his own to do things differently.
It's truly admirable of your dad that he followed with his vision and opened up his own company. And I admire that. So growing from a small company and like you said, 250 employees and different projects that are there. So you guys are doing, I was on your website earlier and you just to name a few, you do VC battery, VC count, and then the VC security was the one that really caught my interest at reading about it. Could you give a little explanation to those three different categories?
Yeah. So we have our main business line, which is the non-destructive testing line. But then there is the VC count is our electronics label. The VC battery, a pretty interesting one. It is doing very fast CT scans of batteries. So if you look into a gigafactory of Tesla, for example, these things churn out batteries in between 1 to 2 seconds per battery. This is the pace at which these batteries are getting produced. So you need ultra-fast inspection equipment. And what we've developed is a computer tomography scanner that scans a battery a second. So you can imagine how fast this thing has to be to really do that at high resolution. Mm-hmm. And our VC security line is our public security business, which produces mobile bomb diffusion or bomb detection equipment. So you are aware of the systems at the airport that the TSA operates. These are the stationary systems. But if somebody just put a backpack somewhere and nobody knows what's inside, then the response units come there with one of our portable X-ray units and kind of look inside the baggage and make sure that there's no bomb or IED or other things inside.
Wow. That's pretty amazing. I'm assuming something like that is utilized through multiple different countries, maybe not just only in airports, but in bomb units. And I feel like, unfortunately, this day and age, there's, always either one mass shootings or bombings of some sort. So that's would be some pretty great equipment to have on hand. That's awesome.
Yes, especially in the Middle East, there's a lot of demand for these things, unfortunately, right now. You look a couple of miles to the east, you look at Ukraine, there's a lot of need to deal with all this leftover ammunition. And this is where these systems are used. It gives our employees a great sense of purpose to play part in making the world truly a little bit safer through that technology.
So you're talking about just to go backwards, the non-destructive testing. So I guess to scan something, or you're saying non-destructive is obviously you're not taking anything apart. You're testing, or like for the batteries, to be able to scan those, they don't have to get broken down and the integrity is held. Do a little bit more explaining that, because
Sure.
I feel like I just mishmashed through that.
No, you got to the point. So these batteries, I mean, effectively, if you're sitting on an electric vehicle, you sit on a bomb, effectively, because there's a lot of chemistry just beneath you that has a lot of energy packaged up inside. And if that thing malfunctions, it melts this car to just a clump of metal because it gets incredibly hot. These things are incredibly to take out. Firefighters have a lot of pain with dealing with these new EVs. So what, of course, all these manufacturers are trying to ensure is that they are functioning correctly and that there is no, maybe a short circuit that results in a fire. How can that be ensured? Only by non-destructive testing, because what you cannot do is open every battery and look whether it's broken, because once you've done that, the part is broken. Yeah. So people do that and sample from the line and maybe cut open every 100th part, but that's not a sustainable measure. So this is where our equipment comes in and really literally looks at every battery, every casting, every electronics part that's coming off a manufacturing line, and then using image processing to make sure that there is no defects on the inside.
So you go then to the manufacturing site and this equipment is installed there.
Exactly. So
okay.
Exactly.
Right. So
our company is providing the equipment that's being used by our customers in their production plant. We also offer something we call inspection services, and could be much more compared to, let's say, a radiologist that has a CT machine. So people come to us with their parts and we give them a verdict of whether it's good or bad, but that doesn't scale. If you have an R&D department and you have 3 parts, you can bring it to somewhere and get it scanned and not, buy a complete CT scanner. But if you're a production facility like Tesla, you need to have your own equipment.
This episode is brought to you by xraytech.org, the rad tech career resource. If you're considering a career in radiology, check out xraytech.org to get honest information on schools, degree options, career paths, and salaries. When you were talking about x-raying the cast, is that making sure that there aren't like cracks in it?
Exactly, yes. Especially the safety critical ones are more important. Let's imagine the part where your wheel is attached to in your car. It's called a wheel suspension. So this is a cast part out of aluminum casting because we want to be sustainable these days. So we use aluminum and not anymore steel. But the challenge is with aluminum, you have incredibly thin structures because you want to be as weight effective as possible. So just a tiny crack or a tiny porosity could make the part fail. On the outside, it looks great. But if you go maybe in Germany on the Autobahn, you can do that. You go, 150 miles an hour. You can do it. You shouldn't, but you can. And then it breaks because this is when the forces are applied. So we look inside, we see the porosity, and then this part can be rejected.
It's interesting, like you said, it's truly put to the test. So if there was a crack in it, that it would at that high. Yeah, I think in the United States, our speed limit is, maybe 80. They don't really want you traveling any faster. Not to say that some people do not, but
it's not advisable. Just because you can, you shouldn't.
Right, exactly. I agree with you there. So you guys have a lot of great stuff going on. Have you met any challenges along the way with trying to develop these new processes?
Yes, a lot. For companies to implement that, there's challenges, starting with the price. X-ray machines are nothing cheap. In the medical world, that's the case. But in the industrial world, it's even much bigger because we have less scale as the medical industry. The human is from an engineering standpoint, an incredibly standardized part to look at. If you put it like this, right? We all kind of like are roughly the same size. We have a head, mostly. We have a lung. We have two legs, mostly. But it's something you can standardize around. If you want to standardize in the industrial world, it's much harder because you can look at an aircraft wing the one day, and you can look at an additively manufactured turbine blade the next day. You could look at an aluminum part or a honeycomb carbon fiber part, and the next day you look at an Inconel super alloy that is highly X-ray absorbent. So the variance is incredibly high, and this increases obviously the costs for people implementing that. But then there's everything that's around regulation. So you need to have people that are trained in operating X-ray equipment. You need to have the regulatory approvals to actually be able to put them to work. You need to supervise them, you need to maintain them. There's a lot of challenges for our customers. And obviously we as a solution provider, we face the same issues in a highly regulated environment where you need FDA approvals and FDA accession numbers and all these interesting things that you need.
Right.
And even then, just putting the physical tool in place is just one part of the story, because you need to do something with the data. And that kind of like brings us to where we focus a lot now, the AI-driven automated image processing algorithms that actually find these little defects. And this is where the tie back to the medical world is. You are also looking kind of for defects, I would say. I mean, if you look for a tumor, that you could say is a defect. That's something that shouldn't be there, it's an anomaly.
Sure.
And it's very, very similar in the industrial world. This porosity is a defect. It's a tumor in the part that shouldn't be there. And this is where we invest a lot of our time and effort into these AI algorithms to automatically find them. Because finding skilled X-ray techs is incredibly hard these days, especially if you're in a factory in Nevada working 3 shifts, 7 days a week. That's not something many people want to do.
Yeah, so that brings me, you guys have expanded from Germany and now you're in other parts of the world.
Yes. Well, our humble beginnings are in Germany, north of Germany to be precise, close to Hamburg. Our first subsidiary that we opened abroad was in Atlanta, in the US. So the US is really one of our most important markets as a very industrialized country with a lot of need for high-end machinery and equipment. But we are also active in Brazil and China and India. So truly global.
So you have different manufacturing sites in all of those areas?
Yes, we partially have manufacturing sites, even though the core comes out of our factory in Germany, and then we just built the enclosure and the surrounding. So it's really not sustainable and not sensible to transport a 30-ton lead room around the world if you can produce them locally. So we try to be really smart about what to localize, what to do in the local economies, and what to do from a central technology hub.
So challenges that you face, but obviously you guys are doing something right, that you keep growing in different countries and you have these different areas that you do your X-ray on. Do you guys set goals like yearly? So you have the VC security, like how long did that take for that to come to light, or even for like the VC battery? You know, how long does it take for an idea to come to fruition? I guess I'm really asking.
Yes, the VC battery is a good one because we've just founded it last year. So the seed was planted the year before the last year. So we get contracted or contacted by a big automotive OEM that needed a solution. And we had an idea and scaled that up very quickly into a business on its own. And this year alone, we are looking at an order intake of 50 to 20 million just coming from that division alone. So we are scaling quite quickly just by the way we are set up in an agile mindset, having the startup mentality still within us. And this is what makes us so successful. And it's funny that you mentioned quarterly goals, because we manage the company by what is called OKRs, so objective key results, which is a very cool technique to manage performance, because you're not setting out these long-term yearly targets and then measuring milestones along the way, but you're casually meeting with the people you work with once a quarter, and everybody sets their own targets for the next quarter, which is then called an OKR. So it's nothing that's mandated top down, but it's a bottom up approach where everybody says, I want to achieve these 3 things. And we write them on the wall and we note them down. And that's how we drive things forward. Obviously, we check that they are in line with the broader vision and the broader goal, but they are self-set, intrinsic targets coming from the people.
So different ideas coming from different people that come forth. So not necessarily that, say, like yourself or your dad came up with one of the new processes that you guys are doing that might have came within the company that, and everyone worked towards doing it.
Absolutely not. We focus a lot on a lot of empowerment of the people. We try to hire the smartest people we can attract. It would be very arrogant to tell them what to do. Obviously, we need to run in the right direction, but we try to manage the company more like a fleet of speedboats and not like a big tanker. And this fleet of speedboats really brings success. And this sometimes, endeavors fail. This is part of the journey. Not everything works, but maybe 70% works. And those 30%, this is just part of the process. This happens. And this is in our corporate culture that these people are then not shamed or they are a failure. But we need to fail in order to win.
Right. And not to say that your failure now wouldn't be a success later. Sometimes
Absolutely.
you just haven't figured it all out on how to make something work, but it doesn't mean that it can't.
Absolutely.
Right.
Yes, you're absolutely right. There's a famous example in this, which doesn't come from our industry, but it's the 3M sticky note. So that was considered a failure for years because it didn't stick. And 3M was in the business of developing tape that sticks. You needed to find a purpose for this thing that was being built. So we have that many times, that there's an innovation or an idea or something that's been built that just doesn't fit. We shelf it and maybe it's dead forever, or we pull it out and use it for a different application. But this requires creativity and openness of mind.
Mm-hmm. So where are you guys looking for to the future? I mean, do you guys have a plethora of ideas that you're working on, or are you looking at what you currently have and honing that even more? Where are you guys moving towards in the future?
There's one big dimension in which we focus on, and that's software and artificial intelligence. We have started roughly 6 years ago to completely focus nearly all of our development efforts, development funds, activities on these fields. And we have achieved quite a breakthrough there. For example, our Compass, our AI-powered automatic image processing tool, has a detection rate, a true positive rate for porosities, for example, of 98%, which is by far exceeding the detection capabilities of a human. And I think you can see similar things in the medical world, where I think AI is exceeding the detection rate of human doctors, of radiologists, with a much higher consistency and a much faster pace. So the whole digital world is where we focus most of our attention these days.
Yeah, AI is just blowing up everywhere. But it's great. I mean, in the medical world, they're using it as an aid for the radiologist. It's not taking the place of the radiologist. And the radiologist, different companies that I've spoken to on the podcast about the AI technology that's out there, that it's being used, like I said, they have the ability to go with what's being suggested by the technology or to not include it. Say if, they're looking at a node on a long image, do they think it's suspicious? It's being highlighted by this technology. They can put in there for you to follow up, or even other AI technology helping radiologists produce the readings just to make their workflow go a little bit faster. But at the end of the report, they have to okay it, basically, like they don't have to go with what the report is generated by. But it's great that the digital world is exploding. I feel like it's come such a long way, from like the early 90s dial-up days to now we have computers doing lots of stuff.
And it's the same in our industry, by the way. Currently, we are talking about assistant features that these AIs are providing. But let's fast forward a little bit and let's look into the future. And if you would ask me, I would say that will not last forever. And if I look at the rate at which AI is improving and getting better, and the rate that humans are improving due to our nature, right? We are where we are over millions of years. I think the human cannot keep up with the diagnostic task that's been put to us. AI will, my strong belief, it's my humble opinion, and I'm not saying this will be the case, but AI will be better than humans at certain diagnostic tasks in the absolute near future. Mm-hmm. And this does not mean that humans are not necessary anymore, but this means we humans can focus a lot more on what we humans are good. And maybe now I'm making a comment towards the healthcare world. I think we don't have enough time is interacting with people, interacting with patients, and delivering maybe tough messages and doing the empathic world. And I think that will be something that humans will have to do a lot more, both in the industrial world but also in the medical world, interpreting AI results and delivering them to humans and being there for the human interaction, because this is what we are truly good as living beings.
Mm-hmm.
While the AI is super good at detecting anomalies in large amounts of data.
Right. That's a good way to look at it. So, I mean, not to be on a whole spiel about the AI, but like you said, it's there to help humans, but ultimately humans are the ones that are developing it. So, I mean, it's really doing what we're telling it. It's not like the computers are all being crazy on their own. But it's so interesting how you don't realize that AI is integrated into so many different parts of your life, systems and stuff. So, moving with the digitalization with your company and everything that you guys have going on, I mean, you've got so much. You guys really have to be truly proud of where the company has started and where you currently are now.
Yes, absolutely. It's something to be proud of. But I think there's just so much more we can do and so much more that is being worked on. It's definitely an exciting time to work on these technologies, because there is so many breakthroughs left and right with cloud connectivity, AI, robotics. It's a fun time.
Yeah, for sure. So everybody, this is Lennart Schulenburg with me today, talking about a different realm of X-ray, probably definitely scanning things that are within your household, or like he said, your cars or your batteries. So really interesting conversation. Thank you so much for sharing your wealth of knowledge, and what you guys do there.
Thank you. It was a pleasure.
Great. All right, everybody. My name's Jen Callahan. I have Lennart with me, and we're going to say goodbye for the day, but check in with us next week for another great topic that we'll be going over. Thanks, guys. You've been watching The Skeleton Crew, brought to you by xraytech.org. On the next episode, join us to explore the present and the future of the rad tech career in the field of radiology.